Welcome to the POS Bioscience and AOCS Method Training webinar. My name is Lance Workman of AOCS, and it is a pleasure to be co-hosting today's webinar, POS Biosciences. I appreciate the opportunity to tell you a little bit about AOCS before we begin the method review. Founded in 1909, the American Oleokimia Society is the driving force behind advancements in oil chemistry. AOCS has been the publishing voice for researchers and has promoted the science and technology through analytical methods, proficiency testing, peer-reviewed scientific publishing, and by organizing conferences around the world. Today, we will see a video from the POS Biosciences Laboratory demonstrating two methods that relate to saturated, cis-monounsaturated, and cis-polyunsaturated fatty acids in marine and other oils, and fatty acid composition of marine oils by GLC. After the video, there will be a live Q&A session with the experts running these methods. Now, I would like to introduce Ben Kelly from POS Bioscience to tell you a bit about their company and kick off the rest of the webinar.
Thank you, Lance. The POS group of companies are an innovative R&D bioprocessing group that customizes inventive answers for clients across the global marketplace. POS creates and analyzes value-added products and ingredients from biological materials of all kinds for uses in food, supplements, nutraceuticals, cosmetics, biofuels, and medical devices. And with that introduction, we will start the video featuring the AOCS CE1I07 and CE1B-89 method.
When starting the fatty acid composition analysis, the first thing we do is subsample our sample and weigh it into a round bottom boiling flask. It is critical at this point that the sample is mixed well, because you want to be subsampling from a sample that is homogeneous and uniform throughout. We weigh approximately 0.1 grams into the round bottom boiling flask. And this sample weight is recorded. The next step is going to be pipetting in our 0.5 normal sodium hydroxide and methanol solution into the flask. Our 0.5 normal sodium hydroxide and methanol is going to act as our base catalyst in the reaction. Now we are going to attach the boiling flask to our apparatus. We use a connector to attach the boiling flask to the condensers. The condensers are going to have cold water flowing through them, and the heating pad is going to be turned to high temperature. It is important to allow the sample to boil for at least 20 minutes. During the boiling process, you will see the sample actively refluxing. So you will see the methanol evaporating and then condensing in the connectors and then dripping back down into the flask. During this stage, while we are refluxing, we are also saponifying the sample, which is going to release and liberate the fatty acids that may be connected to the backbones of the phospholipids and triglycerides. It is also important during the refluxing stage that you see the fat globules go into solution while boiling. After the sample has actively refluxed for 20 minutes, the next step is adding our boron trifluoride and methanol solution. This is our acid catalyst. To begin, we always rinse a couple times into a waste bottle. This ensures that there's no air bubbles in the tubing and we are accurately dispensing the correct amount of boron trifluoride. Next, we're going to add our heptane. And our heptane will be added through the condenser as well. Once the heptane has been added, we turn off the heating element and we allow the sample to cool down. Once the sample is cooled, you'll see that the heptane layer has separated out to the top. It is the heptane layer that will contain the extracted fatty acid methyl esters. We can now remove the boiling flask from the apparatus. And the next step will be adding our internal standard to the flask. For the internal standard, we use C21 that is made up in heptane. This is made up once a month and is stored in the fridge. It is important to be as accurate as possible when adding the internal standard and to ensure that all internal standard has been added to the flask from the pipette. Now that the internal standard has been added, next we're going to add our saturated sodium chloride solution. To begin, we fill the flask approximately half full and we make sure to swirl the sample well. Once we have swirled the sample well, we can continue to add the saturated sodium chloride solution until it is almost full. Once you've added your saturated sodium chloride, we now need to let the sample sit. We want to let the sample sit until the top heptane layer becomes visibly clear. Once the layer is visibly clear, we can now subsample from the heptane layer into a GC vial to run the sample on the GC. When subsampling from the heptane layer, we typically rinse with the heptane layer a couple of times to ensure that we're not putting in any sort of contamination into the GC vial. The amount of microliters that you add of the heptane layer to the vial will depend on the type of sample. Once you've added the heptane layer, the next step is to add 1 milliliter of heptane to the vial. And after the heptane has been added, we can cap the GC vial. It is important to ensure that the cap is on secure and it's not loose to allow for any of the heptane to evaporate. The sample is now ready to be injected onto the GC. We also run a check sample when we run samples. The check sample we use is GLC 756. This sample is prepared monthly and is run every time we run samples and is stored in the freezer. The vials are placed onto the autosampler tray of the GC. Everything is set up through the Empower software, so samples are injected through the software. The parameters of the Empower software, we follow the operating conditions for the GC as listed in the AOCS CE 1I07 method. Once the samples have been run, we can now integrate them using the Empower software. This is the most important part of running the samples, is the integration. You can use reference material, mixed or individual standards, or other identical sample types to ensure that your sample is being properly and accurately integrated.
Thank you all for spending your valuable time to learn more about AOCS methods. As always, we appreciate your comments and feedback, so please send any thoughts or ideas for other webinars to tips@aocs.org. We will now begin the Q&A session. First question we have, what is your advice on how to quantify highly overlapping peaks?
One thing you can do if your peaks are overlapping quite a bit is you can adjust the amount of microliters that you're diluting with the heptane layer when you're subsampling your vial. So let's say you started with 100 microliters, you ran the sample, realized that you were unable to properly integrate because the peaks were overlapping. You could go down to 50 microliters, rerun the sample, and you'll notice that your peaks become easier to separate from each other. You do want to be careful when doing this though. As you continue to dilute, you're going to start losing a lot of your other peaks, especially if they're smaller peaks. So it's kind of a handoff on how well you want to be able to split peaks of importance and how much the others hold an importance in your sample.
Thank you, Lindsay. Next question. Procedure, CE 1I-07, the procedure states that you can dissolve FAME with N-hexanes or N-heptanes. Do you have a preference, and how will using one or the other affect your end results?
Currently, when we do fatty acid composition in-house, we use heptane as our solvent. However, you can use hexane, and both of them will give you pretty much identical results. So it just kind of comes down to a preference of what's easier for you to source or what you have in-house or what works better with you.
Thank you, Lindsay. Once again, thank you all for attending, and thank you to POS Biosciences for opening their lab and sharing their knowledge. Angie Johnson would like to close this webinar with a few remarks.
Thank you, Lance. Again, thank you everyone for taking the time out of your day. We hope you learned something from watching us demonstrate the AOCS CE 1I07 and CE 1B89 methods. Feel free to visit our website, pos.ca, to find out more about